Okay, guys, so here we are in IS number 21, part 2. Does labeling menus reduce calories? So again, this is the hypothesis test for a difference in means. So it says, according to a Stanford Business article, Americans may eat fewer calories at restaurants if the calories of the food items are labeled on the menu. And I'm sure you've experienced this, right? For me, it wasn't Starbucks. It was when McDonald's started posting their calories, made me a little bit sheepish about what I was ordering, made me think about it a little bit harder. So I'm sure that you have felt this feeling. Well, they're going to see if it's really true for a wide variety of people. So to investigate this, researchers compared Starbucks receipts from locations where the menus were labeled to receipts from stores where the menus were not labeled. A random sample. So this is not an experiment. They're not assigning people to go into the store. They're just looking at receipts after the fact. So in that case, they had to have a random sample. So a random sample of 30 receipts from stores with the menus labeled had an average number of calories. Okay, average is telling me a mean. I know this isn't a proportion now. I know we're looking at averages of 225 calories with a standard deviation of 100 calories. Okay, so out to the side, I'm going to start kind of recording what I know. Looks like this is my first sample, so I'm going to call it N1 is 30. So that means X1 bar, my first sample mean, is 225, average number of 225. And then S1, my standard deviation for my first sample is 100, it says. Okay. So then a random sample, there we go. I have another random sample of 40 receipts this time from stores without menus labeled, showed an average, there's my mean, of 265 calories per receipt with a standard deviation of 75 calories. Okay, so that's the other information I know. N2, it says, is 40 receipts in the second sample. X2 bar is an average of 265. And S2, the standard deviation for the second sample is 75. Okay, so I'm noticing the sample mean for the second group for the non-labeled menus is larger than the mean for the labeled menus, but the standard deviation is smaller. The standard deviation for the first group is actually bigger, right? There's more variation in that first group with labeled menus. Okay, so now my question says, does this provide convincing evidence? That all-important question. I'm doing a hypothesis test. That the average calories per receipt, so the mean calories per receipt at Starbucks with a labeled menu, so they're telling me the labeled menus is definitely going to be my first group, is less than at a Starbucks without labeled menus. So really what I'm trying to look at here, I want labeled menus to be less than non-labeled. That's what I'm considering. So mu1, the mean for the labeled menus, I'm wanting to see if that is less than mu2, the mean for without labels. Okay, now that's not how I'm going to end up writing my hypotheses. I'll come back to that, but that is what I'm trying to test. Okay, all right, so my parameter is going to be that difference, mu1 minus mu2. And again, it's a true difference. So what is it a difference in? True difference in, let's see, the true mean calories per receipt. And I think instead of saying like add a Starbucks with a labeled menu versus a Starbucks with a non-labeled menu, I'm just going to write the way that I subtract. So I'm going to do labeled minus non-labeled. Later on, when I actually have my conclusion, I will write out, explicitly in words. But for now, labeled versus or minus non-labeled is going to give me enough information. Okay, so now I need my statistics. So x1 bar replaces mu1. Mu2 is going to be replaced by x2 bar. Sample means replace them. And I actually need to subtract. So x1 bar was 225 minus x2 bar, which is 265. Now, there's a tendency to always take the bigger number first and subtract. That's not what we do here. We have to make it based on which group represents which. The first group represents the labeled, so that's coming first. I subtract, and I'm going to get negative 40. Notice this should be calories per receipt. It's my label here. Okay, negative 40 tells me that the first group is smaller than the second group. So I have some evidence that this is true. I want to know if I have convincing evidence. So my hypotheses, remember the hypotheses are, the null hypothesis is always that the two groups are the same. And if they're the same, then their difference, when I subtract them, mu1 minus mu2 will be 0. So for the alternative hypothesis, I have to keep that mu1 minus mu2, but now I have an inequality of something, or of some sort, less than, not equal to, greater than. Well, since I want mu1 to be less than mu2, that means that this difference is going to be negative, right? When I take mu1 minus mu2, if mu1 is smaller than mu2, this will be negative. We just saw an example of that right here, okay? The other thing I could do is subtract mu2 from both sides, and I would have mu1 minus mu2 on this side, and if I subtracted mu2 from this side, I'd have 0. So mu1 minus mu2, I want it to be negative, I want it to be less than 0. Okay, and then finally my significance level. They didn't give me one, so I'm going to use that standard alpha equals 0.05. If you chose 0.01 here, or 0.10, that would be fine. It's a choice whenever it is not given to you. As long as you choose something reasonable, right? An alpha level of 0.5 wouldn't make any sense. 0.05 does. Okay, so now we need to give the name of the procedure. Again, this is a 2-sample t distribution because we're using means test, not an interval this time, for mu1 minus mu2. And then I'm going to check my conditions. So the first condition, as always, is the random condition. Now both of these, I have two different samples. Both are random samples, and they are independent of each other. So I don't know if we've really talked about that yet, but the receipts from the labeled menus have no connection to the receipts from the non-labeled menus, so they are independent. The second condition is the 10% condition. So let's see, N1 is 30. That's less than 1/10 of all labeled menu stores. So why did I say that? Well, the population that those 30 receipts came from were from stores with menus labeled. So I can say 30 is less than 1/10 of all labeled menu stores. I think there are probably more than 300 Starbucks stores that have labeled menus. I guess I can't be exactly sure of that, but there are a lot of Starbucks stores. So that's a reasonable conclusion. Then I check N2, which is 40. Is that less than 1/10 of all non-labeled, we're in another room here, menu stores? And again, I think there are more than 10 times 40 is 400, more than 400 Starbucks stores who have non-labeled menus. So that condition has been met. In general, that condition will be met. You don't have to worry about it as much. All right, again, the normal condition here, we have 3 different ways to check it. Population distributions could be normal. We don't know anything about the population distributions. N could be greater than or equal to 30 for both of them. That's true for us. So I'm gonna move forward with that one. N1 equals 30 and is greater than or equal to 30, and N2 equals 40, which is greater than or equal to 30. So the CLT applies. Check. Okay, conditions are met, so we can go to StatDisk, go to analysis, but this time hypothesis testing and a mean of 2 independent samples. We'll do that in the next video.